Ya, Assalamualaikum warahmatullahi wabarakatuh. Dan so hari ini kami dari Group 13 akan present about application of fluid mechanics in CFD, which is computational fluid dynamics. So next slide is introduction.
Okay, saya akan membincangkan tentang Introduction to Computational Fluid Dynamics, CFD. Okay, contohnya, what is fluid flow? The physical discipline of fluid dynamics evolved as the sciences started to classify the natural power and associated reaction of air, water, or gases is the fluid flow. The typical fluid dynamics problem involve basic fluid properties like velocity, pressure, density, and temperature. In everyday life, we can find fluid flows in meteorology, heating, ventilation, and air conditioning, and aerodynamic design. Next. What is computational fluid dynamics? Computational fluid dynamics, CFD, is the emerging field of fluid mechanics in which fluid flow problems are solved and analyzed using computational methods and numerical algorithms. In fluid mechanics, there are generally three routes of works in the field, which are theoretical, analytical or experimental, and fluid mechanics. Next. Why we use CFD in daily life? CFD provides a qualitative and sometimes even quantitative prediction of fluid flows by means of mathematical modeling, numerical methods, software tools. CFD enables scientists and engineers to perform numerical experiments, for example, computer simulation, in a virtual flow laboratory that enables architects to design comfortable and safe-living environments, designer of vehicle to improve the aerodynamic characteristic. Next. Here is the differences of experiments and simulation. Okay, next. How CFD problems being solved? Usually, solving CFD problem involves three important stages, which are number one, preprocessing, number two, solver, and number three, post-processing. Okay, next. Okay, next I will talk on available design and specification. Number one, CFD simulation for preventing cavitation. Cavitation is the formation of vapor bubbles within a liquid and occurs when an object such as propeller moves through the liquid and increasing the pressure. Bubbles form when the pressure inside the pump falls below the liquid's vapor pressure. This formation and collapse is both rapid and violent. By CFD, the main objective is to produce a mesh that will suit the physics and geometry. Okay, next. CFD simulation for laminar and turbulent flow. Fluid flow is classified into two main categories, which are laminar flow and turbulent flow, which had been taught in class. CFD simulations use turbulent models to predict the effect of turbulence on a CFD engineered design, which is substantial and make a big difference to the simulation results. Okay, next.
Okay, I will explain about the simulation of CFD for heat, ventilation, and aircon, or HVAC. As we know, HVAC is the system that provides heating or cooling for commercial buildings and also for residential. And we can find it everywhere. Okay, next. The main objective is to of this system is to provide the comfort environment for us and also help to maintain good indoor air quality. Okay, next. Okay, firstly, the simulation of CID for passive ventilation is very important for HVAC system, where it also called as natural ventilation because they use the elements, natural elements such as air, and the engineer take advantage of the physical properties of air uh, to the way of it move and also the behave in order to increase the ventilation inside the building. And the advantages is no cost or low cost of moving air through building because of the wind outside the building, and also can reduce the total energy use and also can increase comfort. Okay, next. And this is the pictures of the prototypes of simulation CFD of a shopping center with 3 level, and this experiment was done with 3 conditions. And the first condition, when all windows is open, and as you can see, uh, there have a lot of motions inside the buildings when all windows is open. So as an engineer, we know that we need to keeping the air speed inside the buildings under the certain threshold. So this is very important, and this design is not acceptable. Okay, next. And the second condition is when the ground floor windows is open and still have the motion inside the buildings, and this design so is not acceptable. Next. And the third condition is when all the windows is closed, and this design still allow the air to perform the ventilation, as we could expect that there's recirculation or circulation at the bottom floor of the buildings. And but as an engineer, we take the result and we need to innovate it, and maybe we can put some construction elements that will block the air from getting into the building. Okay, next. And the simulation for ventilation equipment can help to analyze to for the pressure distribution inside the equipment, also the velocity and the flow path. Next. And while the simulation for displacement ventilation can help to analyze the size and also the location and also the strength for the output of the displacement diffuser, and this can be the great strategy for the engineer to maximize their efficiency and also maximize the potential of their own product. Okay, next.
Okay, next I will describe about pipe and valve simulation with CFD. Fluid flow can exert immense pressure pipes and valve, and also can lead to critical deformation and failure if it is a property account fault. Flow coefficient is an important performance index associated with the energy efficiency of a valve. An effective method to evaluate valve flow coefficient is necessary for valve industry. However, theoretical estimation often result in poor accuracy, while experimental measurement involves significant cost in time and equipment. So, computational fluid dynamics or CFD is proposed to achieve simple and accurate evaluation of valve flow coefficient. For each valve, a conventional fluid dynamics model is established containing a valve section and upstream section and downstream section. Next. With CFD simulation, engineers can model the performance of an entire system of pipe or isolate a single component like a valve to decrease the likelihood of failure. Next. The next point is simulating electronic cooling with CFD. Next. All electrical is used today requires some form of heat management, whether it is seen vent, fans, thermal component, or a combination. It's because chips like GPUs and CPUs begin to malfunction as they overheat. Their components need to be kept relatively cool to maintain performance, usually under 85 degrees. Next. Here are the three main steps for the CFD calculation as been described in the instructions. Next. Next point is turbo machinery CFD simulations. Conventional fluid dynamics or CFD play an essential role to analyze fluid flow and heat transfer simulation by using numerical methods. Turbo machine involve internal and external fluid flow problem in compressed and turbines. CFD at present is one of the most important tools to design and analyze all types of turbo machinery. Turbo machinery is a mechanical engineering concept that describes machines that impart energy from a rotor to a flex. Aircraft jet engines are a common example of turbo machinery. Next. The main benefits of CFD for turbo machinery is that can analyze has the ability to predict correctly the change in any direction of flow and is reliable, and also a potential to utilize the three-dimensional nature of the flow to restore undesirable features. Next. And the common issue is the accurate understanding of boundary condition is perhaps one of the most difficult tasks. There are numerical errors are commonly obtained utilizing CFD due to finite difference approximation. Next. CFD software is used extensively in the design and optimization of turbo machinery. Next.
So kita akan move to hydrology meteorology simulation. And for this is one of example of the material is plastics, polymers, glass, metal and cement. Dia dekat dalam manufacturing. So next is using technique ni like blow molding, thermoforming and extrusion. The manufacturers can shape these solids into a final product. Then this is the example of a simulation of CFD simulation using hydrology. And then we move to simulating reacting flows and combustion with CFD. So the flowing fluid that are chemically reactive uh, reactive of in the case of combustion engine, for example, are referred to as reacting flows in simulation. And this type of flows represent a difficult physics problem for engineers. Dia juga boleh predict the behavior of reacting flow at a chemistry bench scale. Then this one is the example, as you can see here. This is a visual and this is experiment picture, and this is the CFD simulation shown. Then we move to incompressible and compressible flow with CFD simulation. So compressible flows refers to a fluid flow where density is not constant. Incompressible flow refers to a fluid whose density changes are negligible regardless of pressure. So this is the example of incompressible and compressible flow, as we can see. So we move to related fluid mechanics theory. So we have choose aerodynamic to further explanation. So first one is drag force. As you can see, how drag force macam mana drag force ni ada dekat. Then the second one is pressure drag, as you can see here. Then this is the drag force equation, which is FD equivalent to 1/2 rho v squared A CD. CD refers to drag coefficient. Then surface drag, this type of drag is due to the stress and drag values, which is from the friction between A and the body surface. Then lift equation. Lift equation depends on the density of the A, the square of the viscosity, velocity, and A's viscosity and compressibility, the surface area over which the A flows, the shape of the body, and the body inclination to the flow. So secara umumnya, ia bergantung dekat body shape, inclination, A viscosity, and compressibility adalah sangat kompleks. So this is the equation for lift force, which is FL equal to 1/2 rho v squared ACL. So this one is turbulent alumina, which is explained by Daniel. So there are different type fit over the vehicle body. So first one is streamline flows, second one is stagnation, third is separation bubbles, and fourth is Reynolds numbers, and five is turbulence, six three-dimensional flow. Vortices we have learned in our fluid mechanics too. So aerodynamic principle is first is Navier-Stokes equation, as you can see here. So when it is under 133 meter per second, then the equation there. Then for then we move to Bernoulli equation. Ini adalah sangat penting dekat aerodynamic. Ini adalah equation dia. So sama juga bila di bawah 133 meter per second, ini adalah equation. So sebagai resultnya untuk Bernoulli equation, P over rho plus V squared over 2 equal to constant. So I move back to Izan for conclusion.
In conclusion, computational fluid dynamics software was a useful method to simulate the fluid flow behavior with the relevant governing equation. The performance of a conical diffuser with various half angle was determined by using CFD software. It is important tool in many branches of science and engineering. Result mostly typical over 3D pastime. CFD calculation require simultaneous solution of many sets of differential equations, typically involve the first order rich quota in 3D space. Visualization of CFD data is an important and challenging problem requiring favor use of all available visualization tools and skills. Thank you.
Okay, terima kasih. Thank you all. Thanks, sir.